After death, where do the atoms in your body end up? Will these atoms last forever? What is their ultimate destiny? Since the dawn of human history, more than 100 billion people have died. If we consider the law of conservation of matter, there are some atoms in your body right now, probably from an ancient person over 1,000 years ago. Even dinosaurs from 100 million years ago. 60% of the human body is water, then 20% is fat, 15% is protein. What's left is the carbohydrate salt. Molecular structure of oxygen, vitamins. More than half of the human body is composed of water. So after death, this water first evaporates and is lost from the body, or enter the atmosphere, or infiltrate into the ground, and a very small number of water molecules will float in the air for a long time. But in the long-term role of attractive forces and the Earth's environment, get into this water, eventually participate in the Earth's water cycle, such as being heated into steam to form clouds. Then it falls in the form of rain. It flows into the river, and some of that water has evolved over time. Drink again. Plants will also absorb some of the water, with carbon dioxide in the atmosphere and the sun. They were used together for photosynthesis, and it produces carbohydrates and yang. So every breath you take in, the oxygen atoms in it, it may come from water particles in an ancient human body. Except for water, what you're left with is just soft tissue and bone. And soft tissue is mainly composed of carbohydrates, fat and protein composition. There are about 100 trillion bacteria in the human body while you are alive. These bacteria are mainly found in your gut. The immune system controls the population of these bacteria so that they don't over-reproduce. But when people die, the body's immune system disappears. In this way, these bacteria will go unchecked, consumes residual soft tissue in the human body. Bacteria eat soft tissue and harvest energy. They reproduce in large numbers. The process of soft tissue being eaten by bacteria, it's like a slow burn. Soft tissue is essentially a collection of biomacromolecules, and these molecules are consumed by the bacteria into smaller molecules, like water and carbon dioxide, but a significant proportion of bacteria. It needs to work with oxygen. As the body decays, oxygen also slowly diffuses into the atmosphere. Final consumption. Soft tissue tasks will be anaerobic. Bacteria to host. These bacteria don't need oxygen. It metabolizes tissue, and it produces methane, hydrogen sulfide and ammonia compounds, and finally releases an extremely unpleasant odor. These gases are then expelled from the body, enter the atmospheric circulation. Then some of it will be made into ammonia fertilizer, turned into nutrients for crops. Then the house's fruit is used again. After the nutrients in it are digested, turned into feces again. A large amount of nitrogen, phosphorus, potassium, enzyme, and other elements released into the soil in the form of compounds. Then it is absorbed by the plant again into fruit. The fruit may be hard labor or rice. These fruits, it's made into pasta or rice, eaten by humans again. This is after death, the process of normal metabolism in the body. And today, most societies use cremation. During the cremation process, most of the original components of the human body, the child is basically converted to gas. These gases are water vapor, carbon dioxide, carbon oxides and sulfur. released into the atmosphere in the form of oxides. The rest will be in solid form, turned to ashes. The ash is mainly composed of bones, so it's mostly phosphate and calcium. Of course, it's also left in the human body a small amount of radioactive elements, such as radioactive potassium. These elements may decay through radioactive decay, spontaneous fission, so after death, radioactive fake has not had time to enter the biosphere. It decays into calcium. Actually, there are still traces of soil and glaze in the human body, isoeolian elements. Eventually, it will also decay into lead, and in the process of decay, will release alpha coefficient particles. It's called the Hyuanzi nucleus, but because the attractive force of the Earth is not very strong, the damage released by decay, some will escape into space. These damages may be caused by the Sun, or the attractive force of other celestial bodies, and a very small part of the sea. It may continue to travel through the universe, into interstellar dust. The future may fly out of the solar system, even the Milky Way. So after death, most atoms will still flow to Earth. A few of these atoms will decay. Examples of decay releases could fly out of the solar system. Here's the question: if atoms are static, does that mean atoms at the birth of the universe? It may also be present in our bodies. For this question, it involves quantum mechanics, the problem of proton failure. This is also a flower in the history of modern physics. Big dark cloud, we know. Atoms are made of atoms. Nuclear and extranuclear electron clouds. Atomic nuclei are made up of protons and neutrons. The type of atom is determined by the number of protons. So to change an original word, he has to change his proton count. Under normal circumstances, the number of protons in the nucleus is relatively stable, won't change easily. But that doesn't mean death. The quantity is absolutely constant. Because atomic nuclei decay in probability, this decay, electrons and other particles are usually released, but the process of decay cannot be precisely predicted. Statistically, we will use atomic nuclei decay into half the original amount. The time required is standard. Become half-life. And different atoms and half-lives are completely different. For example, the half-decay of element B209, more than 11 times the age of the universe, but we still can't say that B209 is eternal. Because it essentially depends on the quality. Can the child decay? This is what we call radioactive decay. It's not really the decay of the proton itself. If protons can decay, then prove it. All atoms have a theoretical lifespan. Because the number of protons changes the type of atom. Once protons can decay, that atom must change. In example physics, proton decay is just a fake. Sets radioactive decay. As protons decay, will become lighter subatomic particles, such as mesons and positrons. Its downtime is 1.2 to 9 times 10 to the 34th year. It is approximately 129 meaningful years. But so far, proton decay has never been confirmed. There is still no solid evidence to prove substantial particles have the potential to decay, because in the predictions of the standard model, the proton is the lightest seed. So protons are also the lowest energy seeds. According to the principle of minimum energy, particles at their lowest energy, it is also the most stable particle. Protons don't decay. Right now, it's just the standard model, and the grand unified theory predicts that protons can decay. If protons don't decay, then before the destruction of the universe, atoms are eternal. If protons decay, so that's a really, really long time. It's almost equivalent to eternity. So after death, except in the body, beyond a tiny fraction of radioactive atoms, the rest of the atoms will last almost forever. Constant existence in the universe, the ultimate fate of these atoms. Depending on 5 billion years, will the Earth be destroyed by the Sun, becomes a red giant and swallows it? If the Earth were swallowed by the Sun, all the atoms on Earth finally may become white dwarf, the composition of a star. Atoms will be compressed to extremely high densities and counter white dwarfs with electron pressure. The attractive force of exploration. So the ultimate fate of atoms on Earth. It is likely to become a very high density of white dwarfs, sexual raw materials,